This video is going to cover section 13.3, measures of relative position. Okay, so to kind of introduce this unit here, we have an example that talks about movie download times in minutes and in standard deviation. So we have two different ways that we're measuring this. So let's say you and your friend downloaded a movie, okay, and it took you, let me get a color here, it took you 6 minutes to download that movie well, it took your friend 20 minutes. Okay. Now, according to, the average or whatever, the arithmetic mean, so this number here is 12 minutes, which means that on average, it's 12 minutes to download that movie. Okay. So this shows if you go by the minutes here, that you actually had a better deal here because yours was 6 minutes below the mean. So yours was way faster. And your friend was 8 minutes above the mean. Okay. So this is one way to measure the the relative difference in this. Okay. Another way to measure it is using something called a z-score, and that relates to the standard deviation. Okay, so it tells us up here that the standard deviation is 4. Okay, and if you compare that to the 12 here, well, 6 is approximately, let's see, 6 minutes away from 12. That would be 1.5 standard deviations away from the average. Whereas this one is, since it's in 4, it's going to be 2 times. So if you think of it this way, 1, 2, 3, 4, that's one standard deviation, one SD. And this is another 1, 2, 3, 4. That's another SD. So that's where you get those two standard deviations from. Okay, over here for the 6, we have 1, 2, 3, 4. So that's one standard deviation. And then 2, so it's 1.5. That's where you get that 1.5. Okay, so the point of this is that we can calculate the differences using this this method here, which is actually useful when it comes to you know different types of data and information. And that number, that calculation there, is called a z-score. Okay, so a z-score describes the position of a raw score, so that x or whatever you're talking about, in terms of its distance from the mean. So you saw that when we were doing the little accounting there, okay? When measured in standard deviation units. The z-score is positive if the value lies above the mean. So let's say if our mean was right here, okay, here's our line. If it's anywhere over here, then it's positive, that would be above the mean, and negative if it lies below the mean. So negative would be, of course, this side over here. Okay, and we have a curve here that's actually used quite a bit in statistics, but we're going to talk about it briefly. That describes, or not describes, but that shows kind of what this looks like. So this would be our z-score. Okay, the z-score, if it's 0, okay, if it's 0, that means it's right on, it's spot on. Okay, if it's greater than 0, well, it's gonna be everything on this side. This is all the positive stuff, and this is all the negative stuff. So what the goal is when you're calculating these z-scores, just to get as close as possible to your 0 here, okay, to get to that center. Now, let's say if you were talking about test scores, well, if you're talking about test scores and say the average test score was landed here, whatever that is, a 60 or something, then obviously you want to be over here on this side. So it's just different ways you can use this graph for, okay? All right, so here's how we calculate a z-score. We have our score, so the number that they give us, like what we saw before in the previous section with the soda and the ounces, okay? And then we have the mean, which could also be written as such, okay? Depending on if it's a sample or if it's the whole population. And then we have our standard deviation. So what you do is you subtract these and then you divide by the standard deviation. Easy as that. Okay, so we're going to go ahead and just start with an example. This one's already done for us, so we can kind of see how it works. It says that Raul has taken 2 tests in his chemistry class. He scored a 72 on the first test, for which the mean of all scores was 65. So the mean for this one, we'll call it x1, was 65. Okay, and his score was a 72. So let's keep that in mind. And the standard deviation was 8. So standard deviation is 8. Okay, remember that this is the symbol for standard deviation. He received a 60 on the second test, so 60 is our second x. I should have put x1 here. 1, these are all the first ones. Okay, for which the mean of all scores was a 45. So this mean is 45, and the standard deviation is 12. So our second standard deviation is 12. Find the z-score for each test. Okay, so you can see here that the z-score for the first one, we just plug it into the formula. So it's this number, 72, minus the mean, divided by our standard deviation, and that gave us 0.875. Okay, and then we did the same thing for the second test score, which was a 60. So 60, the score, minus the average, the mean, divided by our standard deviation, and that gave us 1.25. Okay, so the question was, did he do better on the first or the second test? Now, at first glance, you might want to say, well, he did better on the first test because 72 is bigger than 60. But the question is relative to the other students, in comparison to the other students, okay? So for that, we need to really look at these numbers here, okay? Notice that 1.25 is higher than 0. Remember that curve that we had, something like that, right? This is 0, and 1.25 would be the somewhere right here. So whereas 0.875 would be a little bit closer. So if we want a high test score, you want to be as far to the right as possible. Okay, so because of that, we would say that Raul scored better on the second test than he did on the first test, because the second test score is farther to the right, away from 0. Okay, so it depends. A lot of it does depend on the question, what they're asking. You know, they say which one is closer to the, to the center here, then it would have been this one. But we want to know where he did better, so it would be the second test. Okay, and that's how you do one of these. So let's go ahead and try some examples. It says, which of the following 3 test scores is the highest relative score? So we're going to do the same thing we did in the one before. We have a score of 65 on a test, so this is our x. This is our mean, and this is our standard deviation. So that would look like the following. We would have, we'll call this Z1, okay? 65 minus 72 divided by 8.2, okay? And I did calculate this beforehand, so this is going to give us negative 0.85, okay? For the second one, we have a score of 102, so there's our x. On a test with a mean of 130, there's our mean, and a standard deviation of 18.5. There is our standard deviation. So Z2, let's call this Z2, would be 102 minus 130 divided by 18.5, which is approximately negative 1.51. And then we have the third one, a score of 605. So there's our x. So let's call that Z3. So 605 minus, with a mean of 720. So there's our mean. So minus 720. And a standard deviation of 116.4. All right. And for this one, we got 0.98. Okay. So they're saying which of the following 3 test scores is the highest relative score. So you kind of, again, have to think about that curve that I showed you before. Remember, we had, here's my 0, 0, and this is where the z lands, something like that. So we can see that negative 0.85, we'll say this is negative 1 here, is about right here somewhere. So Z1 is right here at negative 0.85, okay? And Z2 would be negative 1.51, somewhere over here, negative 1.51. And then Z3 is, let's see, here's 1. So Z3 is somewhere, it's actually really close to that 1. So here's Z3, okay? So it looks like the closest one to my center here is going to be this one by a little bit, okay? So this would be our answer, letter A. All right, cool. Let's go ahead and try another one. Actually, I think that's it for this. This is a pretty short lesson. So let me go ahead and just show you a couple other things here. And we can finish the video. Okay, so we have that a consumer group tested a sample of 100 light bulbs and found that the mean life expectancy of the bulbs was 842, I guess, hertz, with the I'm not really sure what that is, 842 H, okay, with a standard deviation of 90. One particular light bulb from the Durabright company had a Z-score of 1.2. What was the lifespan of this light bulb? So here we kind of have some values and we had to work backwards. Okay, so what we're going to do is we're actually going to substitute the given values into our z-score and solve for x. So 1.2 was the z-score. So that's this right here. Okay, and then we had 842 was our mean, I believe. Let's see. Yeah, the mean life expectancy was 842. So that's this number right here. That's my mean. And then the standard deviation, it tells us, was 90. So this number here is 90, and that goes on the bottom. And this is just a simple algebra problem. We go ahead and, multiply and all that. So what we're going to do is we're going to solve for x. So to do that right here, in case you're not sure what happened here, we multiplied both sides by 90. Okay, that gets rid of the 90 down here. 90 times 1.2 gave me that 108 right here. So 108 is equal to x minus 842. We add 842 to both sides, and you got 950. So it tells us that the light bulb had a lifespan of 950. I'm guessing that means hours. Yeah, that's probably what that means, hours. Yeah, this is just one of those. This would be like a solve problem, solve for x type of problem. Okay. I don't think you're gonna have one of these in your homework, but you might have one in your exam. So definitely write this down. Okay. All right, so now we're going to talk briefly, just very briefly, because again, this would be like the next lesson about a percentile. So a value x is called the pth percentile of a data set, provided p% of the data values are less than x. So what this means is we're going to see where does that score fall under, pretty much. Okay, so to show that, I just have an example here. It says, according to the U.S. Department of Labor, as of May 2009, the median annual salary for a physical therapist was 74,480. Okay. If the 90th percentile for the annual salary of a physical therapist was 105,900, find the percent of physical therapists whose annual salary was the following. Okay, so pretty much kind of going back to that middle thing I showed you before, the median is 74,480. Okay, so if you make more than that, that would be A. If you make more than this, okay, that would be like the middle. So this would be this would be your 50%, by the way. Okay, so anything more than that would be more than 74,480. Does that make sense? So there's A. For B, less than 105,900. So that's somewhere over here, 105,900. And it tells us that that is our 90th percentile. So this is 90% right here. Okay. And I forgot to label that up here. That's why the median was a 50%. Okay. So anyway, this was 90%. So they're saying less than this. Well, it would be less than 105,900. So 90% of all physical therapists made less than this right here. Okay. And finally, part C, between these two. So now you're looking at between this, well, you just got to subtract. Okay. So 90 minus 50 is 40%. So 40% of the physical therapists earned between those two amounts. And yeah, that's pretty much it. Nothing too crazy about this one, just kind of being able to take these numbers, okay, and put them into percent where the percentile is. And I think, oh no, we still have one more. So how do we calculate that percentile? Okay, so this is kind of observing the data. And here we have how to actually calculate. We have given us the data and a data value x. Okay, the percentile of the score is equal to the number of data values less than x divided by the total number, and then times 100 because it's a percent. So here's kind of an example of that one. I think that might be the last one. It says, on a reading examination given to 900 students, okay, Elaine's score of 602 was higher than the scores of 576 of the students who took the examination. What is the percentile for her score? Okay, so we have the number of data values less than 602. which would be this 576 right here. Okay. The total number of data values, well, that was 900. Okay, that tells us right here. Okay. And we just divide this and multiply by 100. So it ends up as 64, which means that she would be in the 64th percentile. Okay. And I believe that that is it. So just to kind of quickly recap, because this might be our last lesson for this summer session, these final examples here, guys, are going to be extra for this week, but they might be on your final exam. So just be ready for that. As always, if you have any questions, please let me know.